Welcome everybody. This is our second webinar with the Land Lake Lecture Series with the Cannon River Watershed Joint Powers Organization. My name is Ryan Lerman. I'm with the University of Minnesota Extension. I cover ag and natural resources in both Rice and Steele counties. I want to let everybody know that this webinar is being recorded, and we will get a recording out to those of you who are interested sometime after this webinar is done. For today's webinar, we're going to talk about soil organic matter. And we're joined by Al Kraus, who's going to represent the Cannon River Watershed Joint Powers Organization. And we have Jodi DeJong-Hughes, who is with the University of Minnesota Extension. And I will turn it over to you, Al, to kick us off.
All right, great. Hello, everyone. It's great to be with you. Let me see if I can successfully load the slides that we were able to load a little earlier. And bear with me. Okay, let's see. Are we up and running?
Yep, looks good.
All right, great. That's what I need to hear. Thanks so much, Ryan. Again, thanks everyone for being here today. It's great to be with you. My name is Alan Kraus. I am a soil health specialist with both the Steele and Rice Soil and Water Conservation Districts. I've been working with the organizations here for a little over a year and a half, I suppose now. Prior to that, I worked with Clean River Partners, a nonprofit out of Northfield, Minnesota, pretty much doing the exact same work. And prior to that, I was a dairy farmer in central Wisconsin for 25 years. Moved over here to Minnesota back 10 years ago now. So to get things started here this afternoon, I'm just going to give you an overview of what the Cannon River Watershed Joint Powers Organization is, what the Cannon River Watershed Joint Powers Board is. This map here that's in front of you shows the outline of what is the Cannon River Watershed or the Cannon River drainage area. Primarily the Cannon River, which starts off in the western part here of both Rice and LeSueur counties, and then runs eastward into Faribault. The main tributary into the Cannon River is the Straight River, which comes south out of mainly Steele County, joins up with the Cannon in Faribault, and then Cannon runs northward, and then heads east to Cannon Falls, and then finally empties into the Mississippi at Red Wing, Minnesota. The different colors that you see on this particular map represent the different counties that are the main counties that make up what's the Cannon River watershed area. Here, this slide shows sort of the distribution. The watershed itself is pretty large. It's just under 1 million acres. About half of the watershed is dedicated to agricultural production. You see a small portion of it is the metro area. It's a significant amount of linear miles that represent waterways or water courses here. Again, as I mentioned, the two main streams or rivers are the Cannon and the Straight River. That block that's in the center on the bottom talks about the land that each county has that's within the watershed, the distribution of the counties. And then, of course, the watershed is broken up into these different study areas, if you will, or different lobes, as they like to call them. There's the Straight River lobe, and then the three portions of the Cannon itself. It just turns out, of course, that this whole effort really to come up with the Cannon River Watershed Joint Powers Organization really began quite some time ago, probably 10, maybe even 15 years ago now here in the state of Minnesota, around this concept called One Watershed, One Plan. And really the idea is that it's the most cost-effective way to address really these soil and water resource concerns really, because the water doesn't stop at the county lines. If you think back to that map that I showed you, right? I mean, the watershed's pretty large, and there could be different resource concerns around the watershed, and finding where those resource concerns are really key or real contributors needs to be found and addressed at a watershed scale. One of the major resource concerns still within the watershed remains to be soil loss. I think we've all seen photos like this driving around the watershed. A number of projects are underway to help control erosion and soil loss. These are just a couple of them that are listed here on the screen. Some of the primary things that you'll be hearing about today really is going to be around conservation, tillage, and cover crops. Additionally, in terms of the practices that are on the landscape, these ground level practices, there's a significant effort underway in terms of outreach and education. In addition, the other efforts that lead to water quality improvement, such as shoreline surveys and septic inventories and lake management planning and monitoring, are underway to help track the outcomes of what's happening here within the watershed. Here, I want to use these next two slides to really introduce our main speaker here today, who is Jodi DeJong-Hughes with the University of Minnesota. What you see on your screen here is just what I just chose this morning, frankly, as a random field. It's in Steele County. And you see these white splotches that are on the located around this field. And what really that is showing you is the organic matter loss that has happened over time. And that's what our main subject here is today, is why organic matter matters. I pulled this map off of the USDA Web Soil Survey. And not too many years ago, USDA started providing what is called an organic matter depletion scale. Jodi might talk about this later today. I'm not quite sure what her presentation is on. But this is a system that provides scoring for the likelihood of different soil types and slopes for organic matter depletion. And the scoring goes really from the high likelihood of soil organic matter depletion to moderately high, then simply moderate, moderately low, or low. And again, randomly chosen parcel here. This particular parcel ended up with 50% of this area as being moderately high likelihood of organic matter depletion. About 30% was listed as moderate, and 20% of this particular load field that you're looking at was moderately low. And what this really speaks to is how to manage this field, how to manage this soil. And I do think that that is what Jodi is going to dig into real deeply here. With that, it's really my pleasure to introduce to you Jodi DeJong-Hughes with the University of Minnesota. She's listed as a regional educator, but quite frankly, Jodi, I believe that region is probably North America with her reach. She's got more than 25 years working in this area. Her area of specialization includes tillage systems, soil compaction, and improving soil health. Her work focuses on reducing soil erosion and building soil health to improve the bottom line for farmers here in the state of Minnesota and beyond, and also to help improve our waterways. So with that, Jodi, I'm going to stop sharing my slides and let you take over.
Okie doke. Okay. Screen 2. Oh, okay. Can you see my presentation fine?
Yep, looks good.
Okay, thanks. Okay. Thanks, Al. Thank you guys for inviting me to do this. I always love talking about soil organic matter and the management that goes along with it. And today we're going to talk about why soil organic matter is so important. Also, I am located out of the Wilmer office, so in case you wanted to chat or something. This is a map. I like to remind farmers in Minnesota that we have some of the best soil in the whole world. And if you look at the map of just the US, the darker colors mean that at the higher organic matter levels. So you can see that Minnesota and even into Iowa, we'll give them some too, that we have some of the highest levels. And part of the reason is because we get cold. So, I guess we can say that the winter has some benefits there. But sometimes because we do have such great soil, it's easy to abuse them. And then they rebound a little bit faster than soils that have very low organic matter levels. And so it's just to remind you, we do feed the world. We're proud that we do that, and that we want to make sure that our soils stay productive for a long time, that we can keep doing that. So just a little science about soil organic matter. It's about 58% carbon. So you'll hear scientists talk about, oh, soil organic carbon and soil organic matter, and they'll use them kind of interchangeably. And their soil organic carbon is a part of soil organic matter. It's just same, they're only talking about just the carbon then that's in that organic matter. And organic matter is made up from the things that have lived and died on top of it, on top of that soil. So in western Minnesota, it's tall grass prairie, and we have those deep, dark, luscious soils. There's other ones that have blown in, washed in, that type of thing. So carbon is, think of charcoal, it's black. And the darker your soils means the more carbon you have in them. And carbon really can help with the resilience of a soil. So it means you can kind of, like I said before, kind of abuse it a little bit, or you have too much rain, not enough rain, and things will bounce back quicker than a soil that has very low organic matter. So here's some of the soils, and just by looking at the color, you can, especially in Minnesota, you can tell how much organic matter is in it. The blacker it is, the higher the organic matter. And we know too, like when we're going to buy a field and there's two fields for sale and they're very similar in a lot of ways, but they have different organic matter contents, you'll go with the one that has the higher organic matter, because intrinsically there's something better about it. You may not understand why, but you just know that field seems to drain better. It seems to produce crops better. The crops don't die so quickly if it's a drought. And I want to show you just some of the soil pits I've been in around the state. This is a mollisol. This is a very common type of soil in Minnesota. But based on where you are on the topography or where you are on the state, our soils are going to look different. So this is in the Waseca area. This is in the Crookston area. And here's the top of the soil. So we're only talking about 7-8 inches of topsoil. And I love this soil because it shows these cracks. And what it is when the soil dries and you get those really cracked soils in the summertime, the topsoil falls down into these cracks. And then when it gets wet again, it shuts them up in there. And so that's just kind of it's called the vertisol. And I see them mainly up in the northwest area of the state. This one has rocks, I'm sure. Especially where the glacier had gone, you'll find fields with rocks like this. Heron Lake, you got a little bit more sand in this soil pit. I thought this was a nice ombre, going from lighter to darker there. But you can also tell that there's not as much organic matter in this soil. Fargo, look at the organic matter. Look how deep it goes. Fargo has clay. Nowhere else in the state can claim their claim to fame to clay. And you don't want to. They're over 40% clay, and they crack a lot in the summertime. And I tease that we found a small child down there and reunited her with her parents. They were very happy because those cracks can get really big. Perham's got the sands. They're pretty, but not as much organic matter. Hancock has sand. We also have some clay loams around here too. And Fergus Falls, I love this one. This is where the little pocket gophers, if they're down below, they do bring soil up with them. And when they're up above, they do bring soil down with them in their little tunnels. So this was a nice little apartment complex of all sorts of activity in this field. It was fun. The thing about organic matter is that is something we can change. We cannot change the sand, silt, and clay of our fields unless we're next to a river and we get flooded or something like that. But we can change how much organic matter we have. And so why do we want more organic matter? And we'll talk about that. Now, how do you improve organic matter? I'd actually rather see you improve your goal to be improve your aggregates and your soil structure. As you improve that, that will also improve your organic matter. Changing organic matter can take a very long time, but changing your aggregates and structure in the soil does not take near as long. So here we go from poor on the left side, poor soil structure. You can see it's more individual soil particles. It's blocky, and you can see it's also crusting on this one. And we would like to move the arrow over to the right side where you have more of a really well-structured soil that has a lot of these little aggregates in there and a lot of roots holding it together. And if you look at this, which one's going to blow away? If you have these aggregates, they hold the soil, physically hold the soil together. And so it makes a larger piece that's just harder to blow away or wash away. So the more structure we get in our soil, the better we are on being able to absorb water into the soil. The other thing about organic matter is to keep it going, you need to have residue. So standing residue is really good at getting water into the ground. They literally act like straws. All the water around the base of a stem, or not the water, excuse me, the soil around the stem is looser. So when it rains, it can get into the soil very quickly. And so you can just think of those as you see them out there as straws. You'll get this better water infiltration. I'm not sure if you've seen this one before, but I love it when the NRCS and Soil and Water go out and do this demo where they'll take something like either prairie or CRP and they'll compare it to a cover crop here and a tilled soil that has residue on it and a tilled soil without, well, either no till or very little till with a lot of residue left over, and then no residue left over because of a lot of tillage. And then they rain on top of it about an inch and they collect what comes off the, off of the top, which would be what runs off. And underneath are some holes and stuff that will collect it in the back one that shows what infiltrated. So we want this to infiltrate, especially if we're farming. Well, anybody does really. So what I like about this one, so we'll take these two pans here, and at the very end, they'll flip them over to show you if the water made it through it. So this is the one that had residue. This is the one without. And you can see that this one is still dry, even though they got the same amount of water, and that this bucket here collected how much ran off. So the soil sealed and it ran off. So when you're getting those 2/10, 3/10 inches of rain, we want that to get in. Sometimes it's the difference between 10 bushels better. So when you have a well-structured soil or have that residue to slow down the raindrop impact and let it absorb into your soil, you get a lot more infiltration and it's there for the crop to use instead of running off and putting that into our waterways. And here's a little bit closer up picture. And there's studies that have been done. This one is looking at a strip till versus a double disking. And what they did is strip till in the fall of 2001. And you can see orange is the strip till. And within the first season, they're able to get better water infiltration. More water could get into that soil in a very quick amount of time. So this is how many inches of water could get into the soil in an hour. And if you double disked, it was only about a half an inch. And first year with strip till got you 2.5 inches, and that's where it about stays. And so even though your soil structure hasn't changed yet, your water infiltration will. And then these hold on to water too. So as you increase your organic matter levels from 1 to 3%, now most of the state is sitting at 3, 4, even 5%, but we have a lot of sandier pockets that are more around 1, maybe 2%. And so this is showing you that if you go up 2%, up from 1 to 3%, it's available holding water capacity doubles, regardless if you're on sand or clay. And for every 1% increase in soil organic matter, the holding capacity, the ability of that soil to hold that water increases by 3.2%. So it will be holding on to it for, let's say it gets it in May and June, and then it's there in July and August for the crop. And what this kind of equates, I like this one. It really shows, there's a lot of information on it. So let's go through this. This is how much water does a corn plant take And when it's really grown, it takes about a 1/4 inch of water a day. And this is looking at sand, silts, and clay soils. So you have the sand is the orange and the silt loam is the dark gray. And then the light gray is disappeared. I entertain myself when I'm speaking, so just ignore that. Silty clay loam, so more, a heavier soil is the light gray. And what this is showing is at 1% organic matter all the way up to 3% organic matter, how many days can you go with the corn taking a 1/4 inch a day of moisture from the soil? Can you go without needing a rain or an irrigation? And so to make it a little easier, let's just look at if you go from 3 to 5% organic matter. You can wait in a sand 4 days about, in a silt loam almost 6 days, and in a clay loam about 4 days. And the reason why a clay loam, you're kind of like, well, but that holds more water, but it holds it so tightly, it's not giving it up to a plant. It has such little crevices in there that even the plant root can't get into there. So a silt loam is actually more ideal for giving up moisture to the crop. And it shows here that you're waiting, say 4, maybe up to 6 days for rain. But if you have 5% organic matter, you can wait a week or a week and a half before you need a rain. And if you only have 1% organic matter, you're looking at every day or two, you need a rain to keep that crop growing or irrigation. So it shows how much water that just a percent of organic matter change can make. And so even just if you're down at 1% and you can increase it a 0.5%, that is going to do a lot for you as well. So let's see, it will give you'll be closer to 2 days instead of 1 to 1.5 days. So any little bump can really help. And sands can build organic matter a lot faster than our clays. There's nutrients in organic matter. So you're looking at nitrogen. There's 1,000 pounds of nitrogen, plus or minus, in 1% organic matter, just 1%. So if you have 3%, you're looking at 3,000 pounds of nitrogen in your soil. And it's mineralized over time. You don't want it all at once. That would be a total waste. But it's the microbes. You know how sometimes you fertilize for, say, 200 bushel, but you get 240, and you're like, I wonder where it got the nitrogen. Well, it got it from the soil, the organic matter. Holds about 100 pounds of phosphorus, 100 pounds of potassium, and sulfur and carbon. And I'm only giving this one $20 a ton, but there's a lot more worth to carbon. So in 1% organic matter, you can see about $1,200, $1,300 worth of nutrients. And we're also assuming that, this is 2 million pounds. Is it an acre of soil, 6 inches deep, weighs 2 million pounds. Also remember that when you're hearing about products that only put down ounces, you're looking at 2 million pounds. So there's some products that usually biologicals that, oh, you barely have to put anything down. And it's like, I beg to differ. So the other thing about these little aggregates, these little rounded areas that are less than the size of a pea, is that they help hold up the weight of equipment. So they're the #1 defense against soil compaction. And tillage just physically breaks them apart. So we want to look at how much tillage do we do? Well, is soil and structure that important? Really? Yeah, it is. Because when it gets wet and you don't have structure, you sink. And I like to show this one because it is a track tractor in here and a tired tractor. So, there's even parts where a track tractor can't get into. The other thing about this is you usually sink to the depth of your tillage. So I'm going to say that they do disc ripping and they probably do it about 10 to 12 inches. So that structure is extremely important, especially with the weight of equipment that we have out there. And we're not always able to go out when it's ideal conditions. We just, we just can't. I wish we could. So how do we build our soil health? And I'm going to say, let's talk about how do we build our soil structure. To me, that's almost everything, is soil structure. Plus, it's something you can see. So you don't have to run tests. You just need a shovel. if you look at the USDA NRCS's ones, it's, minimize disturbance, maximize biodiversity, maximize soil cover, maximize living roots. I have one, keep the soil covered. If you can keep it covered with cover crops or with residue, you're well on your way of making better a soil healthier. And I'm quoted as saying that. I just quoted myself right here. So, but biology is something too that is really it's amazing. That's in the soil. We're just learning about everything that's in the soil. Well, we don't know everything that's in the soil, no way. But just kind of looking at this. But if you have happy microbial, like your bacteria and fungi and things like that, if they're happy, then your plants are going to be happy and the farmer's going to be happy. We have things in there like bacteria and nematodes. And, we always hear about like soybean cyst nematode or even corn nematodes, but there are many, many nematodes in the soil that eat other bacteria, that eat other nematodes, that suck on roots of plants. There's beneficial ones and there's ones that are detrimental to our crops. There's actinomycetes. Those are the ones that it smells, that fresh earthy smell when you go out there and till and you're like, oh, that just smells awesome. That's actinomycetes. You're breaking apart their bodies and they're releasing the smell, but they smell good. And then we have fungi. I think everybody knows fungi. You just look in the back of your fridge and there's probably something back there that has fungi on it. In 1 cup of soil, you can have over 9 billion microbes of productive soil. And that can mean 600 million bacteria and 4,000 different species of microbes can be in this cup of soil. And it is phenomenal. Their hyphae, their cell walls, the sticky stuffs they give off is about 5 tons or 10,000 pounds of biomass per acre of soil. So they have a lot of influence out there. Okay, they can make a lot of great changes. And their functions are to find, store, and release nutrients. They also build soil aggregation. They protect against diseases, and the list goes on. So this picture here, which I could not find the source, so I apologize to the person who created this. This is not mine. I could not find the source. So this is a root. The brown part's a root, and then this is mycorrhizae on here that's in green. And you could see how it can physically protect the plant from other things being able to get in there. So we're just now figuring out what a few % of these bacteria and microbes can do. One of them is glomalin or glomulin. It depends how you want to pronounce it. But what it is a plant root gives off exudates. It gives off sugars and sticky stuff out of its roots because it feeds the microbes. It's that important that they have that relationship, that it's going to give them up to 1/3 of their food source. And then the microbes start growing on the roots and they give a lot of benefits to the plant. Now you see these little aggregates here? These were just formed with the bacteria and the exudates that were coming off of this root. So if you pull up a plant, you could look at it and go, that's a birth of an aggregate. You just can see it right there. It's miraculous, it's really cool. So again, we don't know what most of these microbes do, but we are finding out most of them are beneficial and are necessary. So one of the big things about soil structure that is good, one, it helps keep up the weight of equipment. See, this is a well-structured soil over here, and the one on the right is very poorly structured. This one has been moldboard plow for a very long time, a lot of tillage. And what this one on the left gives is pore space, and that is everything. So when it rains, the water can get into the soil very quickly, whereas if it rains on the poorly structured one, it's going to sit there and pond. And you can also see that it's going to have a hard time getting through the soil. There's just not the pore space. It's all small pore space. This root is even having a very hard time. And what it's doing is trying to find the cracks to get through and taking advantage of the cracks and also putting a lot of energy into trying to widen them so it can get through. And you can see that there's not a lot of root hairs on here. There's not the arbuscular mycorrhizae sending off little roots. And it's suffering. Okay, it's not exploring all the soil around it. And if it's not doing that, it's not getting the nutrients and the moisture in that area. So pore space is so much. It also is really good for bacteria and fungi and microbes because they live in different environments. So you got all these little micro environments happening in there. You got, if you're well structured, you have pore spaces that have water or no water, small pore spaces that have water, no water, ones that have air, ones that don't, ones that are next to roots, ones that aren't. So you have this huge community and very diverse community where when you have a compacted soil and a soil that's had too much tillage, you have all small pore spaces where a lot of the microbes don't thrive. They maybe need pore space and air. And if it's like this is wetter, this soil will stay wetter and cooler longer. And there's a lot of microbes that may not want that or thrive in that. This is a CAT scan. You probably have seen this one around. It's pretty cool. Where they took a CAT scan of a soil, and this is all the pore space in here. And so you really look for these continuous pore spaces because they let water and roots into them, and it's kind of like a super highway. So I'm not sure if this piece is in the way, just in case it was. Okay, micropores are less than 1% of all the soil pores. These macropores. So these long, really wide pores, well, wide for soil, are only about 1%. So what do? They move 70% of the water. So they're vital to have your earthworm pores in, their root structures in there, and old roots, and like alfalfa, it's in there for 3 or 4 years. And those old roots create these channels that really help the moisture get into the soil and down. Now, mycorrhizae, this again is a picture of a root, the brown part, and all the little white hairs off of it are mycorrhizae. So they set up shop inside the root. The plant feeds them carbon, and then they go out and collect nutrients and water and bring it back to the plant. It's very symbiotic. It's kind of cool. But they need oxygen. They're aerobic, and they can physically form a barrier like I showed you on that last picture. And they bring in these nutrients. And here's some of the ones that Jill Clapperton has looked at mycorrhizae for years and years and years. And phosphorus, no mycorrhizae, 750 micrograms per plant. You do 44% more phosphorus being brought into the plant based on whether you have mycorrhizae or not. And if you look down here, iron is 71%, or zinc, 71%. I mean, they help out with a lot of scavenging the nutrients where the root can't go. They're about 100th of the size of a root. So they can really fit into all the little cracks and crevices and bring in nutrients. And if you've ever heard of black fallow syndrome, what that is there was no host for the mycorrhizae. So like if you have a drown out spot, or you prevent plant and you don't put anything in and everything's black fallow, if you put in a nutrient hungry crop like corn the next year, they will suffer. You'll get the prettiest phosphorus pictures if you don't put in extra phosphorus. And the reason why is that mycorrhizae was bringing that much phosphorus into the plant that that is free, that you don't have to worry about. Tillage can also cut them up because they're filaments, so tillage just physically cuts them up. Sugar beets, canolas, things like that is not a host for them. If you have them in your cover crop mix, if you have like radish and some of the turnips, if you have it with everything else, you're fine. It's not a problem. Flooding, remember, they need oxygen, and if you flood them, their numbers go way down. And again, they need a crop that they like to associate with. Now the earthworms, these are some of the macropores that they make, these channels that are in here. And this is a Minnesota number. They can recycle 8,000 pounds of soil per acre per week when they're up and going and in more of a no-till situation. Here's one of them that in 2 weeks, this or 30 days, excuse me, this is what they turned over. You take, yeah, and this is a fun one to do with your kids too for a science project. And you can see that they're bringing the topsoil down and bringing the subsoil up, and they're doing a really good mixing job. These guys are very important for no-tillers who are not doing tillage. This is their tillage. So microbes, or excuse me, earthworms are awesome. But tillage does affect them. Okay, it cuts off their channels and it takes a lot of energy to make those channels up to the surface. Earthworms go straight up and down. Red wigglers and some of the other ones will go along the surface and they're more of horizontal. But the earthworms are the ones that make those channels that really help bring the water down. When you till and you bring them up to the surface, they can get disoriented, or if it's hot out, they could dry up because they breathe through their skin and they don't, if it gets dry, they can't breathe. That's why they have that mucus on them, so they don't dry up. If you see a bunch of gulls following you, that means they're eating your earthworms and other insects that you have in your soil. So tillage is not good for earthworms. What do our good microbes need? Well, they're kind of like us. They want a variety of food. They want a stable home. They want oxygen. And they're just like Goldilocks, not too hot, not too cold, not too wet, not too dry. Yeah, they like 70, yeah, mainly about 70-degree soil temperatures. Now on a soil like this, you can take a thermometer, the ones that can read heat from the surface, and you can see this get up to 120, 125 degrees. Microbes aren't working in that. Underneath cover crops, it keeps the soil at a more consistent temperature and moisture. And also earthworms like that better. So, just keeping that soil covered and reducing tillage as much as you can is the best thing that you can do for the soil. So fun fact, if you build it, they will come. The microbes will be there. There's a lot of products out there. Okay, remember we have 9 billion microbes in 1 cup of soil. If you don't have a home for them, they fade off, right? If you add a couple ounces, or I don't care, even add a ton of microbes to your soil, they have to compete with the natives. And if it's a product you have to put down every year, that means they died. That means there was no home for them. So you have no idea if they did anything for you between that, when you applied them and when they died. Probably didn't. Then we're going to talk about erosion a little bit, because this has a lot to do with soil structure, and soil structures related to organic matter. And there's 3 types of erosion. There's wind and water, which we've all heard about, but tillage is actually very destructive. So we'll talk about that. I like these. Don Weiss used to use these in his presentations. And so these are satellite images that show, brown soil through Minnesota here. And this is April through May. Then in May, we're planted, plants are starting to come up, we're starting to fill in the row. Then by June and July, because there are sometimes by July, we're still not full canopy, but there's years that we hit canopy pretty quick. Totally depends on the climate. So then we have, a full canopy finally, everything's green, the soil is protected. It's July. And then October. So July and August, we have full canopy, but really for about anywhere from 6 to 8 months of the year, we have nothing growing out there, depending on the year. So when it comes to erosion, so what that means is when you have all that bare soil, that's a perfect time for erosion, wind and water. And the way that you have bare soil is because of the tillage that you do. 5 tons of soil is a permissible loss by the NRCS. They say, let's just try to keep it to that, which is a dime's width. But that erosion never is this even loss. You see gullies, you see areas where the wind catches more and takes more soil. Just look at the ditch. You can see where the soil fills in, or the ditch fills in more with soil, you got more erosion right there. And if you look at 5 ton an acre, that in over 40 acres, that's 16 dump truck loads of soil. And if I came to your field and said, hey, I just want to take off the top, just your best stuff, um, you won't miss it. I think you would kick me off there pretty quick. Yeah. And that's about 400,000 pounds of soil in 40 acres. That's what you can lose or at least move. So what's the value of topsoil? It's really hard to put a number on it, but let's say we just wanted to replace it with a good black topsoil. If you lost 5 ton an acre and it's $25, which I haven't looked at the increase lately, but say $25 a ton to replace it. So if you had a landscaping business, it's $25 a ton. That equals about $125 an acre of soil that you're putting back out there. You put it over that 40 acres, and that's $5,000 per year. So by losing what's permissible, that's what you're losing. That's not counting, remember, the NPK that is in there. Now, most of us own more than 40 acres, so let's say 1,000 acres. That's $125,000 if you wanted to replace the soil that you're losing in wind and water erosion. So when does wind erosion, and this is an undoctored photo. I'm in Western Minnesota, so this one is over by Wood Lake. And yeah, it gets bad. Anything over 13 miles an hour on a smooth, wide, bare field can pick up soil. Okay? And that's, pretty much every day we have that kind of wind over here. And then there's clay versus sand. So clay, an individual particle of clay is actually microscopic. So it blows. So if you have a couple of days where you are having this really intense wind and your sky is getting gray, that is your clay. And it can move thousands of miles. Your sand and silt usually bounce more across the soil and end up in the ditch. But as they're bouncing, they also hit clay and send it up into the air as well. So there's a lot of processes going on. Now, if you can make those clay particles into an aggregate, it would take a lot more energy to get them up into the air. There's probably about 3 or 4 places in the US that are in red, and that's because they can lose 8 ton an acre or more from just wind, and that's the Red River Valley. Remember I said it has all that clay, and it is very flat because it is an old lake bottom, and the wind can pick up the soil so easily there. So we started going to the ditches and figuring out, I wonder how much is in there. And this one here, you can see has about 45% residue next to it. And it's a fairly white ditch still, not a lot of soil in there. We are on the same road. Here's the windbreak. See there? Same windbreak. And this field has, I am being generous at 15% residue. It's probably closer to 0. And you can see in the ditch here how black that soil is. So we went out to 6 different ditches and took samples. So we went from white to black ditches to see how much was blowing into those ditches. And what we found, it was anywhere from about 3,200 pounds that gathered in a ditch acre to 65,000 pounds of soil gathering in that ditch. That's not what left the field, that's what's gathering in the ditch. And a ditch acre is a half a mile long by about 20 feet. So this ditch here is very, what's it called? It's one of those. So the average of those 6 was about 18,000 pounds of soil were moving into the ditch. Water erosion, this one's on a slope. It's hard to tell because we're doing it from the air, but it is taking out the corn big time here. It washes away your soils and nutrients. And then there's tillage erosion. So Al talked about these white areas that are showing up. And yeah, that's where you're losing. The shoulder of the hill is where you're losing the most soil, and then it's gathering down here. Okay. Some of it, if you have water nearby and the water is moving, now that soil can leave the field. But a lot of it's sitting down at the bottom. And tillage erosion can be more erosive than wind and water combined. Tillage breaks up those aggregates and just makes more fine particles, and it leaves the soil unprotected. And it clogs these pores. So when you get this heavy rain, all those smaller particles are filling in the pore space, and that's where you get your crusting. There's also certain diseases that like to bounce up from the soil that are soil borne. And then when this happens and it's splashing onto the plant, it actually can infect the plant too. Gauss's wilt is one of them. Tillage moves soil up and forward. Okay, so if you're going, we like the speed discs and the vertical till because you can go 10, 12 miles an hour. That means you're also throwing soil 10 or 12 miles forward and not, okay, they're not going 10 miles forward. They're going that fast forward, okay? And yeah, you gotta be careful with that. And then gravity moves the rest of the soil down the hill with wind and water. Okay, so then you get these spots, which means you've lost all that black topsoil that was on top has now moved down the hill and or in the ditch or up into the sky. And oh, I had the quote on how much of that was up in the sky. If you see, yep, I don't see my little note on that. And it's more than 10%. So whatever you see in the ditch, about 10%. No, it's like, okay, I'll find it for you. So how much structure is destroyed with your tillage is going to be dependent on a few things. And one is how deep you're doing the tillage. So, you know, how deep are you going in there and breaking up the soil? How much soil is going to be turned over? So how aggressive are you being with it? Are you kind of slicing through? Are you turning things over? And then how many passes do you make? You know, I have a guy who lives near me who does 2 fall chisel plow passes and 2 spring field cultivations. And I don't think he needs, you know, he could do 1 of each. That's a way to just start cutting back. You don't need to go to no-till. You just look at what you're doing and see where can I change it out. And again, the type of equipment. Our residue levels change based on the equipment we use. So this is field cultivation. The FC strip till is the ST and VT is the vertical till. And you can see after soybeans, which is a very fragile residue, doesn't last very well through the winter. Field cultivation, just a fall field cultivation can turn it almost black. So if you can keep, when you're in soybean stubble, don't do the tillage until the spring. That would be the best to keep the soil covered and protected over the winter. And here we have, you know, if you keep 50% of your soil covered, we're not talking 100% residue out there. The reduction in soil loss is 85%. So that's a huge difference. If we can, like I said, just keep most of the soil covered, we'll be saving a lot of soil. If you're using points or shanks or even sweeps, what it does is it kind of goes through the soil and lifts and separates the soil more naturally along its planes. So it destroys less structure. And so I prefer them over a disc, and I'll talk about a disc in a minute. And if you can't afford a strip till machine or, you know, just something that goes a lot lighter, if you have a chisel plow, you can start by changing out your shanks. So if you have, or your points, if you have a wide one or they're twisted, they are going to turn a lot more soil and bury a lot more residue. So if you can go more to a narrow point and straighter, they do less tillage. And that way you can keep the same machine and keep more residue and just start getting used to that residue, right? Just, yeah, and then you can keep working on it, right? Baby steps are just fine. Now discs, if you see a road being built or redone, you'll see a disc on the side. And the reason why is because it tells the soil where to cut, where to shear, and it breaks up the aggregates. That's what you want for a road. You don't want it heaving in the, you know, in the spring and winter times. And so it makes them all individual particles, but you don't want that in your field, okay? The deep disc for sure, keep out of there. And even the shallow disc, I mean, where does the rain get into your soil? It's the top inch, right? And if you're doing the disc, it takes out the structure there. And so that's when you start getting the crusting effects and pore emergence and things like that. So if you do have a disc, only do it where you have a lot of residue and try to shallow it up as much as you can. I'm just going to talk about this just briefly. Remember I said 58% of your organic matter is carbon. And when you till, you're actually releasing CO2 into the atmosphere. That is carbon that cannot be put back into organic matter to make future organic matter. It's lost. It's back up to the atmosphere. And what we've seen over time, like this dark gray one here is moldboard plow. These all started off as grass, and then we did different tillages to them, or Hoyt did. And you can see here in the gray that moldboard plow is down to 2.4% organic matter from the grass level of 4.5. Deep tillage brought it down to 3.3%, and no-till 3.8. The thing is grass and prairie put in a lot of biomass, a lot of carbon into the system, whereas our cropping systems just, they can't compete. So even at no-till will not be as good as CRP. That's just the cost of farming. So, that's why we want to add more cover crops, because they do add carbon. So you could see the more tillage you do and the deeper you go, the more you're going to lose that carbon, and that will lower your organic matter levels over time. This one's for people who aren't farming that may be on the line. I would love to say, hey, I'm going to give them all the science, and they're going to say, yes, that makes sense. I'm going to change everything. But I don't have to look at their labor needs, what type of landlords they have, seed and fertilizer costs, what the co-op is giving them, as a bonus if they buy this over this, the economics, the risk, the learning curves, the comfort, whether they have children to take over, what the markets are doing, if they have livestock, what kind of debt they have. That's what equipment they already own that they put a lot of money into. So, be supportive, and baby steps are fine. Just think about the system you have and think of one thing you could change, and do it on the back 40 so nobody's watching you. And if it does somehow get to be a mess, I have signs that say research by University of Minnesota, and you could put those out and you can blame us because we're always doing weird things out there anyway, right? So how do you track your soil health? To me, it's a shovel. But the biggest thing, if you see erosion, wind or water, you got to stop that. If you don't stop that, any progress you try to make will not work out. So you want to make sure that your fields have over 40% residue in them when you're done harvesting, and if you do fall tillage. You want to see if you have water infiltration, or do you have crusting issues? Do you have ponding issues? And, how can you stop the erosion? Then take a shovel out there and see how easy it is to shovel through these soils. If it's really dry out, it's going to be hard whether you have a good soil or not. You want to look at these aggregates. Yours won't be like this if it's in a cropping system, because this is actually, the one on the right here is under grass. And unless you're just growing grass and don't have a crop, this is what it can look like. I use it because it just really shows what structure can do. This one over here has 2 layers in it that aren't so hot at 9 inches. So he is chisel plowing or disc ripping, and at 3 inches. So that's a field cultivator. Okay. And everything in between is just, there's no structure. So we're just trying to get more over to here. Just nudge ourselves over there. Also, the soil, when it's healthy, will have a really fresh smell, like I said, with actinomycetes. If there's no smell, or if it's stinky, yeah, you got some problems growing on there. And then the main thing is, what are the roots doing? If the roots are hung up on these little shelves, that's not beneficial for your crop. You need them to go down, and down as deep as they need to go. If there's a lot of moisture out, a lot of rain, they're not going to go that deep. If they hit dry soil, they won't go through dry soil. Okay? So there's certain things that affect roots besides your tillage. So the summary is, Improve the structure and you'll receive less compaction, better water infiltration, more water in dry years, improve nutrient release to your plants, and you create more of a resilient soil that can take these, big rains and more droughty times that we're getting. So the bottom line is keep that soil covered if any way you can. Okay, whether it's with green living cover crop or residue, just try to keep it covered as long as you can. If you want to learn more about soil organic matter, you can go to this link here, SOM Pub. I also have a compaction guide and a tillage guide. All of these, well, the compaction and tillage guide are about 45 pages long, so it talks about the equipment, it goes into depth about a lot of things and all the research that we have. We also have the Soil Management Summit and Dirt Conference, which is NDSU is the Dirt Conference. We're teaming up this year in Fargo, and January 14th through 15th, and it's always my favorite conference, not because I created it, but partially, yeah. But this is my last year, other people are going to take it over, but this is my last year doing it. So come and join me up there and have a great time. If you need to contact me, you can do it by my email or DM me on, I'm still going to call it Twitter. So any questions, or do we have time for questions?
Yeah, so right now we don't have time for questions, or we do have time for questions at the end, but we're going to kick it over to Al here, and he's got a few things that he wants to cover. So if you want to stop sharing, and then Al can jump in and cover his part.
Okie doke.
Okay, thanks, Ryan, and thank you, Jodi. Tremendous amount of information as per usual. Let me see if I am able to find my other slides here. All right, let's see. Are you seeing those slides, Ryan?
Yep, they look good.
Okay, great. Thanks. Again, thank you, Jodi. I will try to move through this relatively quickly. I know that we have a 1 o'clock end time for folks that could possibly stay a little bit longer. I will try to move through this really, really rapidly. We wanted to provide you with some information about the basics of the soil health programs that are available for cost share incentives. There are a number of them. Shoot, I lost my slides. Where'd they go? Here we are. Okay. And what I'll quickly cover today are cost share that's available specifically through the Joint Powers Organization, funding that can come through our local SWCDs, some state and federal funding that might be available. I should say is available. And at the very end, I'll just touch very, very briefly on some of the carbon programs and this program that's called 45Z. That provides incentives for soil health practices. As Jodi was saying, the main thing is to get these practices on the landscape, get out there, get this work happening, and begin to see the benefits. With respect to funding that's available in the Cannon River Watershed Joint Powers Organization, I showed you the map earlier. They have these different levels that they're calling them. What really is, it's just different areas of resource concern. Level 1 being the highest area of resource concern. You can see it's mainly a drinking water supply management area. And then 2 other areas of resource concern, sort of based on the work that was done to set them all up. Mainly what we're looking at here are covering cost share for cover crops, reduced tillage, and within the JPO here, perennial crops. Not going to go through this slide in any great detail other than to just sort of get it on your radar how the funding is set up for cover crops. Again, 3 levels of funding depending on the area where this field or parcel that you have falls, and that's depending on the resource concern in that area. With cover crops, you can have a 1-year contract or a 3-year contract, and you can have either just a single species cover crop that you plant, or you can plant a mix of different species, and based on those parameters, you fall into a certain cost share category. Also have funding available through the JPO for no-till and strip-till, so reduced tillage practices. Again, the 3 levels of funding, along with what we call rotational or continuous strip till or no-till. Rotational means you're going to move that practice around from field to field to sort of meet and fit in with your rotation that you have on your farm. Continuous means it's going to be either continuous strip till followed by no-till beans, for example, strip till corn, no-till beans, or just continuous strip till or continuous no-till. Continuous practice pays a little bit higher than the rotational moving around. These contracts are for at least 3 years. Within the JPO, again, I mentioned there are perennial crops. This does not include anything like alfalfa or pasture grasses. What's shown in the photo there is intermediate wheatgrass, also known as kernza. So that actually is a perennial grain crop. Again, these types of plants have to be on the ground for 3 years. And again, based on where you are in the watershed, level 1, 2, or 3, we've got a cost share level laid out there. What I want to say to you right now is that this entire program is run by the local SWCDs. And again, here in the Cannon River watershed, those are those 6 SWCDs that I pointed out earlier. And so call your local SWCD office if you have any question about that, and they can walk you through the funding that's available through the JPO, watershed-based implementation funding. In addition to the JPO money that is available to the SWCDs to bring out to the farms, there's also other local SWCD soil health programs that are funded through the Board of Water and Soil Resources. By the way, I didn't mention the JPO funding also is through the Board of Water and Soil Resources, but rather than follow the whole watershed as a whole, the counties, each of the SWCDs are provided some funding to work with you directly as a county level. And again, there's a grant that's called the Soil Health Delivery Grant, cost share available for cover crop, strip till, no-till, as well as planting green. And then a new program that came out basically just this year in 2025 called the Soil Health Practices Grant, funded through this program that's called RCPP. That's the Regional Conservation Partnership Program, which is funding that comes through the federal government. And I listed here all of the different practices that are basically available. The ones that I enlarged there, cover crops and the residue and tillage management, the windbreak, those are sort of the main ones that, at least here in Rice and Steele County, are being offered as programs for cost share. Again, you will contact your SWCD and find out more information about exactly what those cost share levels are, because they do vary by county, because these are county level type programs. More soil health funding programs through the Department of Agriculture here in the state of Minnesota. Three key ones that I wanted to just point out to you was the Minnesota Ag Water Quality Certification Program. This is a program that has a 10-year life associated with it. They do provide cost share for various practices, basically the same ones that I've just been mentioning. And cost share is available per year for an amount of really $5,000 per year, and it could last up to 10 years. You do need to be putting in new practices to be awarded that cost share, but it is available. There's also what's called the Soil Health Financial Assistance Grant, and that grant it runs annually. It pays for about pays up to 50% of the purchase price for equipment purchases, or a total amount of $45,000. So you could buy a $90,000 planter, for example, and pay $45,000. There's also what's called the Ag BMP loan program, not talked about very much, but this is a low interest loan program that's run out of Department of Ag through the local counties. And it does support equipment as well as projects and practices. For example, cover crops can be a practice that can be funded through this Ag Loan BMP program. But folks usually use it for things like purchasing large pieces of equipment and get it at a low cost loan. The loan rate maximum is 3%, and you will work through both your local county as well as through your lender to be eligible for the Ag BMP loan program. So just some of the state programs that are available. There's also federal programs that are available primarily through the NRCS. This is the Natural Resource Conservation Service. And the two arms for their soil health programming is really the Environmental Quality Incentive Program, That's EQIP, better known. And then there's the Conservation Stewardship Program, also known as the CSP. And again, I just listed that small set of practices there that are part of their soil health programs that they have open. There's quite a few more, frankly, quite a lot of them. You will call your local NRCS, your USDA Service Center, and you can talk with the representatives about NRCS programs. Again, it's very similar cost share concepts that I've mentioned for these local programs, but you'd be dealing with federal folks in terms of getting those practices on the landscape. And I'll just quickly end with this. These been talked for quite a few years now already around carbon programs. And there's an organization called the Conservation Technology Information Center. And they've developed what's called the Conservation Connector. And I've got the website up there. And by the way, for everyone that is registered and listening in today, we'll send you a follow-up email with all of the links to these pieces of information, as well as the presentations from today. But I just put in Goodhue County, for example, Minnesota, and was interested in cost share programs that might be available. And this in blue is not even the entire list, but they have all of these different programs that are available. You can see the soil health grant came up there, as well as program from ADM and then Climate Smart Park and so on. And all of them will provide cost share for different aspects on your farm. This again was just specific to Goodhue County. You put your own county in and what practices you're interested in, and it'll generate these links for information. And then lastly, I just put on here, check with the Minnesota Soil Health Coalition, also Practical Farmers of Iowa. These have been what I'm just going to call sort of aggregators or actuators of some of these climate and carbon programs that have been out there. They've been very active in this space. It's very much worth your effort to just Google their websites and find out what they have available for cost share that's being run through their organizations. They're linked up with some of these organizations like ADM, for example, and can help you get through and find some cost share available for cover crops and tillage and so on. So CTIC, Conservation Connector, has been a really good development. And then lastly, this whole thing called 45Z. Now, what 45Z is simply a tax credit for ethanol plants, a tax credit for clean fuel production. And the concept here is to provide these ethanol plants with a credit so that they could incentivize them to reduce the carbon intensity of fuel production. And what that turns out to be, and one of the ways that they can accomplish that is by sourcing low carbon intensity grain, low carbon intensity feedstock. And in order to do that, in any sort of scale sense, they will need to be providing some sort of premium for the purchase of low carbon intensity grain production. And the way you get low carbon intensity grain production is by putting into place all of the things that we've been talking about here today. And that is reduced tillage, getting cover crops on the landscape, doing better nutrient cycling, finding more ways to grow a great corn crop with not quite so much nitrogen fertilizer, so on and so on and so on. So I just wanted to put it on your radar. 45Z is still sort of in that limbo world where it's in the law, but the details have not been ironed out enough yet to really bring it out to the land. So, but keep it in mind and keep it on your radar. And that's all that I have for slides. And we may still have just a little bit of time for questions if folks want. I know we're running about 9 or 10 minutes after 1 o'clock, Ryan.
Yeah.
If not, we can leave it there. Just maybe some wrap-up comments from Jodi or yourself.
Yeah, so we do just have 2 quick questions here. So the first one said, I mentioned carbon benefits of cover crops. And so they're experimenting with winter kill mix ahead of our 2026 corn crop. And they were able to plant in early October, but will likely not get a ton of growth before it terminates. So they're wondering, are there still measurable benefits from some cover crop growth or are they minimal if they don't reach a reasonable maturity before winter killing? So that was kind of a lot there, but basically, they're just trying to get at like, okay, they planted their cover crop. Are they getting some carbon benefit from that crop before winter kills?
Yeah, well, I'm going to just jump real quickly, and I want Jodi to respond to this as well. Living roots in the soil, Ryan. That's what it's all about. And as soon as you initiate living roots into soil, those roots are delivering those root exudates and carbon and sugars into the soil, which stimulate that biology of the soil. That's what Jodi's been driving home, and that's the point of getting a crop growing. Yeah, the more biomass above ground means more biomass below ground, means more root exudate, means better carbon distribution, so on and so forth. But some living roots in the soil, albeit even small, is better than no living roots in the soil. So that's my take. Jodi, go ahead. Oh, you're muted,
You're
Jodi.
muted, Jodi.
Okay, since you're not using rye is the one that can grow the fastest usually. So if they're winter kill ones, I'm thinking that you're using mainly broadleaf. And so you won't get, it depends the university answer. So with the clovers, they're really good at creating aggregates and working in the surface. And even though you only got, they're just maybe this tall, they do have a little bit longer roots. Again, like Alan said, the more growth that you get, the better. And luckily, we've had a pretty long fall with a couple of rains in there. So some of the things that wouldn't have made it last year, this year's been more conducive to it. So anything you got down will help. And if you're on a program, then you don't have to feel too bad if it's not giving too much. But it is protecting the soil, it is stimulating the microbes, and it's not doing anything negative at all. It's all positive.
Excellent. Thank you. This next question is probably more for Al, if he has any insight. So those programs that you mentioned, are any of them at risk of being canceled by the current administration, or are they secure for the length of the program? So I'm kind of wondering, like some of those you mentioned, you have to have a 3-year contract. What does that kind of look like?
Yeah, good question. Gosh, I wish on this one I could say it depends. Thanks, Jodi. Interestingly, with the current administration, a lot of the work that was done by the Biden administration around this concept of climate smart commodities production, putting a lot of money into that program, kind of had a length of life to it. The current legislation has put that into the Farm Bill. And so there's a longer length of life for secured funding around conservation programming. Some folks have a hard time believing that, but that is exactly where we stand. So that was a huge win for conservation program at the federal level to put that into the Farm Bill permanent sort of concept. Locally, what we end up with is funding programs that generally have lasted about 3 years. The state provides funding to the local SWCDs. It's somewhat variable. Some years it has been at one level, and then it may get reduced and then back up again. And so there's budget constraints both at the state and probably at the federal level that can really sort of limit the amount of money that comes into these conservation programs. Again, it really is just something that you'll need to contact those SWCD offices, contact your USDA service centers, and have those conversations and find out what the length of life is on the programs that they have in place right now. That's probably the best answer to give on that one, Ryan. There is no steady state on any of that funding, quite frankly.
Yeah, for sure, for sure.
And on a different point, totally 180, sorry, I did find the quote on how much soil is in the air versus the ditch. So what's in the air is 10 times higher than what you see in the ditch.
Jodi, can I just, since you brought up the air thing, we saw a lot of wind erosion down here in southeast Minnesota last year. You guys, we see it every year, but this past year in 2025 was very astounding. One thing you didn't mention about what's in that soil, that airborne soil, that's our best topsoil that's up in the air and gone. What does it also contain? All that chemistry that we put down as crop protection, right? That's adheres to those soil particles. That soil particle is now airborne and gone. So that
Yep.
left you as well. But you can imagine we're going around breathing that in, right? So there's additional consequences for letting that soil lift up and blow away. I think we have to really come to grips with some of that stuff. We don't talk about it enough, quite frankly.
Well, and even the Dust Bowl, before you had a bunch of those chemicals, was killing people
Oh, totally.
in their lungs too. Yeah.
Totally.
We also see soybean cyst nematode in there.
Right.
So that's getting in your body. Yeah, you're right. We don't talk about the human health hazard of it,
Correct.
but it's real.
Well, I do not see any more questions coming through. Al or Jody, you guys, either of you have any final comments or anything else that you wanted to add before we wrap this up?
Nope. If you have any questions, email me.
All right.
Yeah,
Well, go ahead, Al. Sorry.
yeah, sorry. Again, thanks for the opportunity, Ryan. Just to end on a confident note here, right? I mean, these folks are making these practices work around the state of Minnesota and around the United States, and they're being very, very profitable with great environmental outcomes and good human health outcomes as well. It's very possible you just need to get started.
And, you know, with the tillage, we didn't really talk about how much tillage costs. And so if you can reduce the pass and the fuel that you use and the time and, you know, wear and tear on your tractor, it really adds up, especially if you're having, you know, things aren't economically so great right now. So do one less pass of tillage.
Yes, absolutely. And I think that's one thing we don't talk a lot about is profitability. You know, everybody's worried about yield taking a hit, but you know, a lot of times they end up being more profitable and the yield hits really aren't as bad as people make them out to be either. So yeah, it's profitable. It's possible to be more profitable than
Oh, yeah.
typical, you know, conventional, and as well, your yields really aren't that far behind. So
If in my research from Western Minnesota into Northwest Minnesota over into North Dakota, they're the same. So,
yep.
and we're colder. So, yep. You just need
Yeah, so
to, you know, research what you're going to do and talk to some people.
yep, yep. So I think everybody's out of excuses now, is the way I see it.
Try.
Agreed.
All right.
Okay.
Thank you both today. I really appreciate you guys both taking the time. And thank you to everybody that stuck with us here till the end. Be watching your email for a recording of this presentation, and we'll see you at the next webinar.
Thank you.
Take care.
Yeah.